confidence intervals for a population proportion. Now, these are I feel are the easier ones to calculate. So notice that the formula is very similar than that for the mean. The p-hat represents the sample proportion, and then this was basically the standard deviation for the sample, and the z star is that critical value. So it's very similar to what we were doing. So again, that square root thing was the standard deviation of the sample statistic. Here are our values for the critical values, and boy, I have another misspelling there. I am got to retype this whole thing for next year. Cannot believe this. So our conditions. We have to have a random sample. We have to have a large enough sample size that n times p-hat and n times 1 minus p-hat must be at least 10. So, oh goodness, I'm cracking myself up because I keep making mistakes, and it's really not that funny. So, let's just get into it because that's the easiest way to figure it out. So, in April 1998, the Marist Institute for Public Opinion surveyed 883 randomly selected American adults about allergies. According to a report posted at the Institute's website, 36% of the sample answered yes to the question, are you allergic to anything? Therefore, the sample proportion who said yes, p-hat, is 0.36. We'll use the sample information to calculate a 95% confidence interval estimate of the population parameter. And the population parameter is the proportion of American adults who are allergic to something. So the sample statistic, that's our p-hat. P-hat, that's 0.36. Now, before I can get started, I need to check my check my conditions. Gosh, I've lost words. So we need to check the size. N times p-hat. It better be bigger than 10. So we got 883 times 0.36. I believe that's going to be bigger than 10. 883 times 0.36 is 317. That's definitely bigger than 10. We also need to do n times 1 minus p-hat. So that would be 883 times the opposite of 36%. Oops. That'd be 0.64%. And that ends up being 565. Again, we're good. Sample size is definitely big enough. Now, our critical value, if we're trying to get 95% confidence interval, when I look back at the chart that was on the previous page, 95%, 1.96 is my critical value. So for 95%, the critical value, so that Z star, is 1.96. Now the standard error, and this is where I probably should have been a little bit more specific, is this standard deviation. The p-hat, 1 minus p-hat, divided by n. So square root of 0.36 times, this would be 0.64, divided by 883. The margin of error is when we take our critical value times that standard error. So the margin of error, which I like to call E, is going to be that 1.96 times the square root of 0.36 times 0.64 over 883. And we end up getting an error of, when I run that through the calculator, let me clear out everything else, 1.96 the square root of 0.36 times 0.64 divided by 883. I get 0.0317. So we would take our sample proportion, 0.36 plus or minus 0.0317. In other words, I'm going to subtract it to get the lower boundary, and then add it to get the upper boundary. So let's think about what this means, that interpretation. We are 95% confident the population proportion of American adults who are allergic to something is between, what would this be when we're talking about proportions? This would be 32.83% and 39.17%. A CNN Time poll of 1,003 American adults conducted by telephone from June 19th to the 20th of 2002 was designed to measure beliefs about apocalyptic predictions. One of the results reported was that 59% of the sample said that they believe the world will come to an end. Calculate the standard error. Let's make it the margin of error of the sample proportion who believe that the world will come to an end. So I want to do the margin of error, which would be my z-score times p hat times 1 minus p hat over n. Now, so for 95%, okay, for the 95%, it's going to be 1.96. Oh, we forgot to check our sample size. 59% of 1,003, I think we're good. The sample sizes can be really good. Sometimes you can look at that sample size and know. The opposite would be 0.41. The standard error, by the way, would just be this square root part. So if it had just wanted that, here I go changing a problem in the middle of going through an example. That would be the standard error. And this is the margin of error. That's how much we're going to add and subtract to the sample proportion to get our confidence interval. So the lower boundary, you would take that 0.59 and subtract 0.0304. And the upper boundary, you would add it. And this ends up being 0.5596. This ends up being 0.6204. So the interpretation would be, I am 95% confident that the true population proportion. Oh, that should say proportion. I can't even spell today either. Proportion that believe the world will come to an end is between 55.96% and 62.04%. Let's go on to the next example. Oops. I flipped the wrong way. Here it is. The Kaiser Family Foundation commissioned an extensive survey in 2004 that investigated the degree to which American youth from ages 8 to 18 have access to various forms of media. They distributed written questionnaires to a random sample of 2,032 youths in this age range. Do you think that's going to be bigger than 10? Yes. One of the many questions asked youths whether or not they have a television in their bedroom, to which 68% answered yes. Calculate a 90%. So 90%, I'm going to look back at my chart. That critical value for 90% is 1.645. Let's see. N was 2032. All right. Calculate a 90% confidence interval for the population proportion. So that margin of error, we would take the 1.645 times the square root of, what was our